we can just install one thing and we get a bunch of cool stuff like reactive programming. We get Hibernate for like a relational modeling of the database, and we get all of these other things. I'm like, why though? Why'd you have this? It's what can you code now that you couldn't before?
Welcome back to Kodsnack, everyone. I'm Fredrik, as usual, and I'm here with Christian. Hi, Christian.
Hello, everyone.
We met. I'm sometimes efficient and effective and stuff like that, and sometimes I'm not. We met at Öredev 2023, and we talked a bit about, wouldn't it be fun to record an episode? And I said, yes, of course. And I put it on my list, and then I guess life happened or something. But we're finally here. Should we say something quick? Who are you? What do you do?
Yeah, so my name is Christian, as you said. I'm a software developer and then turned tech lead. I've been a consultant ever since I was done with my master's degree in programming languages and structure, or semantics, as it's called with a fancy word, but really it's just structure. And I've been coding all of my life, and I live and breathe code. And now lately I've started a company where we're trying to do serverless the right way and revolutionize the cloud.
Oh, that's I like the level of the ambition. It's it really appeals.
It's grown a lot, right? It was first, I was trying to save code bases. I love refactoring. So I was like, I can save any code base, I thought. And then I saw the first code base of 1 million lines. And I was like, I can't save this single-handedly. That's just impossible, especially because other people are adding and messing things up all the time.
Yeah.
And that's sort of where I changed my focus to be like, well, if I should fix 1 million lines, then I need to actually fix the people instead of the code. And that's when the tech lead thing started. And I eventually wrote a book about how I do refactoring and how I make my team do refactoring. It's called 5 Lines of Code.
Yes.
And then I realized that's even not enough. People still are having trouble with their good code, and especially on the service level and microservice architectures, all this gets messy. Yeah. So now serverless. So now I'm building a platform where we'll just fix it. If you use it, it'll be better. We promise.
Sounds good. I mean, especially as someone who's working in a company where we started doing more and more, moving a bit towards serverless, moving more to more multi-component architectures and stuff like that.
Yeah, it's the thing is that's dangerous with cloud is it seemed like it should be, or the promise was it should be simpler, right, to build with cloud than to have your own servers. But then they started adding a bunch of extra things and variants and stuff, and now it's like, well, before you had to choose which brand of RAM and how they work with things and benchmarking and stuff. But now you have to choose which specific message queue do you use for this particular thing, and how do you tie this thing together, and do you use one global or do you use different message queues for different parts? And it's like, I think AWS has about 250 services that you can choose from. And that's just as hard as choosing hardware, right? You just need a different type of expert to help you.
Yeah, exactly.
And so from my point of view, it's like, I'm a developer. I want to write some code, and then I want it to run. I don't care about anything else, right? Yeah. And preferably, it should be fast.
Yeah.
And that's the other thing. People end up often building their software to fit into the infrastructure they have, or to fit around it more say. So like, if there's something a lot of serverless providers have cold starts, and then people are like, cold start's sort of bad, but serverless is really cheap, or comparatively cheap. So then maybe I'll just make another service somewhere else, or a cron job somewhere, that then triggers this thing to keep it hot. And I'm like, now you have 2 things you have to maintain. You're building your software to your infrastructure, not the other way. Yeah. And so all of that I hated, right? I just want 0 cold start, very, very fast serverless. Write the code, ship it, don't think about it.
Yeah, I mean...
and that's what we've built.
Yeah, it's like we start adding services and running in various cloud systems. And then all of a sudden you're sitting there trying to configure an obscure config file of some type and adding variables that appeared when you did the git pull the last time instead of like running the code or something.
Yeah. It's all the decisions and all of it's just so complicated. We had a actually, when we were talking about this infrastructure and building the software to it, I had a project once where I was doing it was a large project. We were doing a big prototype for a company, and we were going to use NoSQL because it was new and it was fancy and it seemed really good. And it was my first experience in practice with NoSQL, and so I built it sort of like a a relational database. So I had one collection for each type of table I would normally have.
Yeah.
And I figured that was fine and everything worked good. And then the bill came, and we hadn't launched yet. This was still during the testing phase.
Okay.
And the database was 11,000 crowns, which is what, like almost 2,000 euros.
Yeah.
And it was like, what did you say? We have only test data. I think we have a few hundred rows, right? It's for
nothing.
a relational database. I wouldn't even have noticed that we were using a database.
Yeah, exactly.
It would have been $0. So it was like, okay, what's going on? But it turns out that you paid an upfront amount for each collection.
Oh.
And I was like, well, it's NoSQL, so it's not tagged with anything. We just put everything into one collection. Although it's very messy, and it's like, so the code became much less clean, but the bill became cheaper. So we started, like, we're building our software to the infrastructure again.
Oh, yeah.
Which is just so dumb. I hated it.
Yeah. Yeah, there is something to good old databases.
I don't want the CFO to be the architect of the software.
No, that's a really good...
Right? Conway said, don't let HR be the architect. And now I'm saying, don't let the CFO be the architect either. Let some architect be the architect of the software.
Yeah, that's also one of the levels. Like, you have to make all these choices. And there's this more or less obvious billing aspect of the choices you make. So you can't...
Less.
Yeah.
Much less obvious.
Yeah. I mean,
really tough.
Yeah, it's like, I have my machine over here. It consumes power and CPU and memory, but that's it. But now, oh no, I made another table mentally in my database, and now I get to pay more. Yeah.
I was working with big customers also as a consultant, and I think AWS had this offering where they could send an expert to tell you if you were using the right services. And so you would have the same exact functionality after they left, so it's a refactoring thing, but the bill would say the right things, like the right line items, and it only cost $100,000.
Oh,
and it's like, what did you tell me?
Yeah,
for the bill.
Yeah,
then it's too complicated. If I need to pay for the bill to be right, it's too complicated.
Yeah.
Make it simpler.
Yeah, it sounds like people telling stories about dealing with lawyers. You know, they bill you to send you an email and stuff like that.
Yeah.
But
it's insane.
Yeah.
But it leads nicely into what I'd like to talk about, which is simplicity and how important it is for software.
Yeah, and how easy it is to lose it.
It disappears immediately. It's sort of the entropy for the real world chaos. It also goes into code.
Yeah,
in everything. It seems it's not just a physical law.
Yeah,
it works everywhere. Chaos just creeps up on you, and it's very interesting. I've always been a very principled type of programmer. I like distilling things into simple to understand values and philosophies and stuff. I talked a lot on my blog and stuff about core values. I have this thing that every time I want to change my job, I have to go and update my core values, because if I chose a job that aligned with my core values and I don't like that job anymore, either I didn't do research up front, so I didn't discover what their values were, or I've changed my values and should adjust them.
Yeah.
And it actually has given me very good grip on what I want to do with my work time and what I don't want to do with it, which I find is really good.
Yeah.
And I've started doing the same thing with architecture. Every time I want to refactor something in a major way, I should think, what are the fundamental principles that are being broken? Didn't I understand them? Didn't we follow them? Or do we need some better ones? And, that's part of this continuous improvement journey that I think is ultimately the most powerful thing, right? Is improvement over time. So it just is, and it's actually, that's one of my personal core values right now, is embracing small improvements every day. And don't expecting miracles in a short time, just so long as it's a little better, everything will work out fine.
Yeah, but I mean, it's hard to find. Sometimes it's even hard to find the place where you can make a small improvement, because the mess is so complex. Or
for sure. And it doesn't happen. It sort of like, so I'm very focused on weight, having just gotten a child, and we're weighing him all the time, obviously, and it's sort of similar to how that works, where it swings up a little bit and down a little bit, and then sometimes it just makes a jump, right? That's when the improvement actually happens. But And if you track everything too often, of course, there's going to be a bunch of statistical fluctuation and randomness.
Yeah.
But over time, you should see, like, if you look back 3 months, you should be able to say, I'm better now. I know I can feel I'm making better decisions now than I were 3 months ago.
Yeah.
And I have this thing of systems, like when you're trying to do an architecture, do a big system, if you have to sit down and come up with good principles to start with, you either have to have a lot of experience from previous projects, or someone who does, or you can take someone from a book or something, but they then hopefully have that experience.
Yeah.
I think an easy one to start with, and one I think should be everywhere, is simplicity. It's just, and Quebec's been saying it for, 30 years at least.
Yeah.
And it just keeps coming back to me how powerful the idea of simplicity is, and also, of course, how fragile that is. I had a fun story, and that's also the reason it was on the top of my mind when you asked me to come on. I had an experience where I was visiting a customer, doing some consulting. I was actually doing an architecture review, and I had been the principal architect of the original idea and principles and stuff. I did them many years ago, like 6 years ago, something. I designed a whole system for this huge corporation, and it was a really, if I do say so myself, a really well-designed system. It had really solid principles behind it, and they were easy to understand, so that when you got into a discussion, you could easily say, oh, are we violating one of these 3 things that Christian said were important?
Yeah.
One of them was simplicity. And I came back, and so it was a system that was built very much actually like the platform we have now, to just work with the basic programming languages. They were using Java, I think. So it was just using basic Java. There was no Spring. There was no crazy framework or anything on top. And that was intentional. That wasn't a mistake. That was very much. Because if someone knows Spring, you could just add it. That's fine. I don't care. But if someone isn't using Spring, then Spring would be a cognitive load, right?
Yeah, it's one more thing
to add.
Yeah.
And so when I came back after 6 years to do the review, the first thing I noticed is they had all these frameworks that they'd added, like a bunch of frameworks. They were like, yeah, we're doing all this cool stuff. Look, we're doing, I think they had something called Quarkus. And it's like, we're doing Quarkus, and it's a collection of things. So we can just install one thing and we get a bunch of cool stuff, like reactive programming. We get Hibernate for like a relational modeling of the database. And we get all of these other things. I'm like, why, though? Why do you have this? What can you code now that you couldn't before? Like, no, look, it's backed by all of these big companies and Red Hat, and like all these people are using it. I'm like, yeah, but can you what problem couldn't you solve without it, right?
Yeah, exactly.
And they're like, no, but look, we can have all this queue stuff and all this asynchrony in the code. I'm like, yeah, that's a negative for me. Though, again, that doesn't help model things. Asynchrony makes it harder. Yeah. And we already had, the model already was built with a concurrency model in mind. So they just added another concurrency model on top of it. Which is like, no, but you're making it a lot less simple by adding things. Yeah. And it was actually a really tough discussion to have with them, because they're like, a lot of people are using it. It looks cool. It's a very sexy thing to say. Yeah. But like, we can use it for employee branding. Like we want to say, oh, we use the latest technologies. We have this thing. Yeah. I'm like, I don't care. It's it's harder.
Yeah. Yeah. I mean, I work mainly in, web front ends. And I mean, we have the same thing in in spades with a node and everything. Yeah, yeah. And I think I only become more and more tempted the longer we go to like start putting more work into actually removing stuff.
For sure.
Because there are so many pieces. Yeah, and some pieces are those gateway drug things that, we added this because we actually needed it, because some things needed it for support. And then that makes it really easy to pull in 5 other things when you need like one little if statement from them or something.
Yeah. It's so hard to keep your dependencies down. It's so important. But like security is becoming a big topic, and I really don't like talking too much about it. It's such a doomy thing to talk about. All security people I've ever spoken to are super downers, because it's never good enough, and it's always right around the corner. Yeah. So, but it is a huge source of vulnerability. Is obviously more dependencies. Yeah. But for me, the way more important thing is you're adding so much weight to the shoulders of your developers if you add a bunch of extra things they have to learn that they can't run anymore. Yeah. And it's not fun if you can't run. we're so like it's so much fun to work in a code base where you can just code away to your heart's content, right? Everybody loves starting a new file and just I can do anything now.
Yeah.
But if you have all these other things, and especially, as I say, for me it should be optional. It's not like I'm saying nobody should use Quarkus. I'm saying if you're already proficient in it, sure, go ahead, it's fine. But for all of the people who are not, it's going to be a limiter, right? It's a barrier to overcome.
Yeah.
And there are enough barriers already. We're solving hard problems. Programming is a very mentally hard thing to do.
Yeah.
And so I want to use all the available brain power I have, or as much as possible at least, on the problem.
Yeah.
So simpler tools, simpler languages, simpler, like use the things you're already good at, or learn things during dedicated learning slots where you're not also solving business problems. And then a lot of companies, unfortunately, also the ones who tend to neglect simplicity a lot, are the ones where they don't have dedicated learning time either. And so then they're going to be stuck forever, right? They think, they'll learn if you just add a bit more stuff. Or we just purchased this new fancy tool from somebody, and now everybody has to use it. Like, okay, what's your onboarding plan? Like, how are we going to get proficient at this? Which developer recommended this tool?
Yeah.
No, it was smart. We saw the sales pitch. We saw all the projections.
Yeah.
What? It's insane.
Yeah, this is really popular.
But
who's using it?
Removing stuff is just so important. It's like it's in a lot of ways. I think it's an easier way to add value than to add stuff. Because
Probably,
if you can remove something without affecting the users negatively, you've added to the code base. The code base is more valuable line for line right now. So I mean, it's sort of like a share buyback, right? Just taking out all the bad stuff. It's a better thing you end up with.
Yeah. I mean, I keep wondering how the web front end I'm working on the web application would look if we actually removed all of React. I mean, that would be a huge job. But for one thing, I don't think it would be slower. The code we had to write might be a little bit messier, but there would be so much other stuff removed as well. Maybe
sometimes, but it's like the one front end thing that you put in is a big chunk. It's one of those decisions that feel it's very hard to change React to Angular or to Vue or whatever, Svelte, whatever you want to run right now. I don't know what the most sexy thing to say is.
No, me neither.
I've been struggling with that decision many times because I've made small app type things and web apps and stuff. But it's more so this idea of there was a famous question on Stack Overflow where someone says, "Hi, I'm struggling with adding 2 numbers in JavaScript. How do I do this?" And then the most upvoted response is, "I think there's a jQuery add-in you can just a plugin you can just install and then have that add for you." And then the next are then there are like 30 other suggestions for libraries you can install to make adding somehow more simple, or logging it with colors or whatever. And then the very bottom one with the most downvotes is you could just use plus. It's literally just how we would normally do it.
Yeah. Oh no, heresy.
But that's the culture I'm really trying to push back on and say, don't just install a bunch of things, even though they seem smart. At least not in production. You can, I'm also a big advocate of having time to practice and to test out things. We do it every Friday. Do whatever you want on that time. That's fine. Test everything. And if it's better, sure, pull it in. But make sure it's better for everyone or most people on the team who's going to use it.
Yeah.
And for a platform and a platform team, which is what I mostly work with, it's horrendous. You should put as little as possible into that thing or hide it.
Yeah.
Really well through like true abstractions. I also talk about this type of ways you can hide things. If you hide something behind a shallow abstraction, it'll still leak through, which means the people using it will still have to be experts in that thing or learn about that thing to use it. A fun example is actually Google's serverless offering is Canico. And the way we found out this is we test all of their competitors, obviously, and there was something we couldn't make Google do. It wasn't in their documentation. Then we looked up the Canico, the Knative documentation, and that had a setting that we could set. And so we were like, let's just try shipping that setting and see what it does, and it just worked. So it's just they've just renamed all the fields. That's it.
Oh,
it's just native, which is like, and that's fine. I don't mind. But it was fun that it's like it was a shallow abstraction. It leaked through, so we could figure out how they had done it. With a true abstraction, we would never have been able to see it. Such as a real virtual machine, you can't actually see whether you run on a virtual machine or on a real machine.
Yeah.
So it's for platforms and stuff. It's really important if you do put in extra things, hide them through true abstraction so they don't leak. Yeah. Just bring down the leaves. There are many more leaf programmers at the edges. Hide all of the stuff that they don't know, so that they could just work with the things they love and they can be productive.
Yeah. So if you add stuff in, wrap it up nicely and keep it from leaking out.
I did, right? Like when we were designing the platform, me and the CTO guy who's doing all the infrastructure and all the Kubernetes stuff and all whatever, I was like, my level of abstraction is data and CPU. That's it. I don't care about anything else. I'm running code or I'm storing data. And everything else is an infrastructure word, right? Yeah. That I don't care about as a developer. Just, I do a git push, build my code, do whatever you want to it. I'll tell you when to run it, and then give me the result. Yeah. It's just, there's so much extra stuff. And another bad thing is we get used to that stuff, right? We get used to the control of it. We get, like, there are a lot of people who love looking at detailed dashboards of what can every little thing do and stuff. It's like, you shouldn't worry about that sort of stuff. You're like, it's a waste of your time. You're way more productive, or your time is way better spent working closer with your users or your customers or whomever you're doing something for. Normally.
Yeah, I mean, you
and then
need
some
to
infrastructure people should look at the details.
Oh yeah. Someone needs to be able to get that type of information when it's needed, but shouldn't need to worry about it, I guess. Yeah.
It was a very, very, I mean, it was almost a traumatizing experience, that sitting there, discussing all of these tools that they had just pulled in. We made a list of, and I think they had 20 tools that were added since I built the original, or helped build the original architecture. And I'm like, you've literally shown me nothing that you can do now with these things. And what was even worse was, we looked at some of the teams who were using it. We went in and audited some of their code. Not to hold them responsible or anything, just to see, were they actually using these things? Were they was there something cool? I need data to support what I'm saying, but my hypotheses was that they weren't helped by this; they were actually hindered by it. And you could just see that they built these very, very, very complicated asynchronous loops for different things, where they would call in a sort of weird order and stuff. And then when we talked to them, we're like, so what are you working on right now? And the first thing they said is, we have this caching thing that doesn't work. And it's like, oh, yeah, we're submitting some things, and due to some concurrency thing, it doesn't work. And I'm like,
I wonder why that could be.
What if we ditch all the concurrency? Like, just and abstract it away somehow. Yeah. What if you do this thing? Like, yeah, we're also doing this scheduling thing, and it super didn't work. So now we're only scheduling one instance, and it's like, you're doing single instance serverless. What? There's no point. Then you're doing a single virtual machine. You can't scale for anything. It's and ironically, another principle that we built into their specific architecture on their request was that they had zero downtime deployment. They wanted rolling deploys. I'm like, that's fine, we can build that. But we can't build it if you set your VM size to 1. No, that doesn't work.
No, it's kind of difficult.
I mean, this is like, so they'd immediately taken 2 of the principles that were designed in this system, and they just ruined them. Right? They were out the door. Yeah. The third one, which is,
We interrupt this broadcast with a quick thank you to all our sponsors on Coffee. You too can become one by visiting ko-fi.com/Kodsnack, Kodsnack, and making a one-time or monthly donation. If you support us with €5 or more per month, you get some very, very nice stickers in the mail. And if you support us on the barista level for €10 or more per month, you also get a huge thank you right here. Thank you, Andreas Legell, Brother, Ingo, and Tobbe Lundberg. And remember, you're a fantastic person, whether you support us with money or not.
My personal sort of, it's my signature almost. It's also what the book is about, right? Bringing down the coupling between things. So the third principle was that things should be maintainable. They should be flexible, which means in practice that you should be able to take a service and split it up into two services without having to contact finance or infrastructure or another development team. Because as everybody knows, if you're asking another development team to do some refactoring for your sake, it's not going to happen. Even actually you getting to do that refactoring is impressive.
Yeah, exactly.
Because they're not going to do anything. And so you can't do direct microservices. With that sort of thing, if you follow the logic, direct microservices, you'll need other people to change if you change the structure of your microservice. So that doesn't work. You have to do indirect microservices with message queues or something else. Yeah. And so we were doing that in the original architecture. And I came back and they were like, yeah, we've also added direct calls because we needed them for something. And I'm like, no, I don't think you needed them. And now you have 0 of the founding principles or the principles of the platform, right?
Yeah. And I guess at each step, someone had a really good reason for every part, but it adds up.
It seems like it.
Yeah.
It's also a question of, actually, I think the platform developers and let's say streamlined developers, to use the team topologies word for it, have different or should have different reasons for adding things and a different adding cadence or change request cadence. Streamlined teams should add everything that their users want, probably in some like ordered fashion that's most valuable to least valuable. They should add every feature, right? If your users want something, sure, give it to them. Whereas for platform developers, I think it's different because we want simplicity is pretty high value in itself. So if I have 2 teams out of 8 asking for some weird framework or something, I would much rather make it possible for the teams to do that themselves than add it to the platform.
Yeah.
And then I would see once 7 of the 8 teams use something, I would then pull it into the platform and like hide it from the last team, sort of thing, or like give all of them the benefit without having them pay the price. But it's if you take normally streamlined developers and just say, now you're a platform developer, they'll continue with this, I should just add this because someone wants it, and the other people can just ignore it. They can't just ignore it.
No.
It's even, and I hear this so much when I talk about the simplicity. It's like, but it doesn't cost anything to add an extra thing.
Oh, yes.
Right? But this is not a pack of donuts. It's not like you're getting 13 and you only need 12. That's not what it is. It's more so that if you put out ice cream, everybody's going to taste it, right? And if I then tell you, this ice cream is actually poison, you're like, yeah, but they can just not eat it. But it looks like ice cream, right? They're going to eat it. Developers can't see a new fancy technology and not be curious. Me as well. I'm not being better here. I'm just saying, of course, you want to if it's there, I want to test it. Especially since I don't have to go through all the trouble of installing it and stuff. It's just there.
Yeah, exactly.
And
you just pull it in.
When you have a hammer, everything's a nail.
Yeah.
So they added reactive programming. Suddenly everything was a reactive problem.
Yeah.
Even though they literally had 0 reactive, like they weren't doing a reactive code base. They didn't have any concurrency needs. It's just, it was crazy. So I guess, I just want people to put simplicity somewhere, give it some value, and then put it somewhere and say, is the value of adding something, especially in a platform thing, but also like I could make the same argument for streamlined things. It would just be a slightly different way. By adding this, are we actually making it worse for the platform? Like, is this actually more simple? Or is it truly hiding something, or is it just adding something and then not even still hiding the concurrency? Because I would argue also that while asynchrony and reactive programming is one exciting model for concurrency, I don't think it's the simplest one.
No.
At least it isn't for me.
Yeah.
And so then we're just paying for it. It's just an expense.
Yeah.
It's not making anything better.
Yeah, exactly. I don't think we've even said it outright, but the thing you add, it has to have some really clear benefit as well. It feels like you should have to, or you should need to show clear enough benefits for adding it in the first place as well.
Yeah. And I guess I'm a little bit atypical when talking about all these things, because I've always hated frameworks, and I pull them in as the very last resort.
Yeah,
I
same
pull
here.
anything. I've used React, sure. I couldn't code my own React quickly at the time. I've since actually found a way to make something that feels like React in maybe an hour or so. It's like really fast, and it's just a way to add nodes to a DOM, and that's most of what React does.
Yeah.
Then there's this whole state thing and things, and I think that isn't simple anymore.
No.
I haven't built a React frontend that was so complicated that Redux made it simpler, at least not in my head. But I'm not an expert in the Redux thing.
No, same here. But I built, I've built both with and without Redux with React, and no, I'm not sure there's a big gain there either. And I mean, I think I do like React in the basics, especially. I mean, we picked it pretty early, and I think it served us really well. We especially had a really great period of a couple of years where it felt like I'm not using React. I feel like I'm just writing JavaScript, and I feel like that's a sign that you picked the right thing for the right situation. I'm not so sure we're there anymore, and I'm not sure anymore whether React is actually a net positive, but mainly because it drags in so many other things. I mean, if we didn't have React and a few things it brings with it, we wouldn't even need a build step, which is kind of appealing.
Yeah, it can certainly be. I've been having some discussions with people about like the job market and stuff, and when we talk about things, back in a few years ago, when let's say before COVID, I'd always been like, well, you could always learn to program, and there'll be a lot of jobs for you because we always need more developers, especially if you're talented. And now that I've gotten a little bit older and can reason a bit more about things, I've chilled out a bit. I can think like, well, actually, if they sit down and learn to code, they have to spend upfront a number of hours learning it, and then they'll have some job opportunity with some salary things. And you have to average out, well, was the salary worth it? Especially, and you have to factor in what's the joy of learning that thing, right? And for me, I loved coding from I was younger than 10, right? I was 7 years old when I learned it. I've always loved it. And so that I didn't need a lot of money to learn. I just did it for fun. Yeah. But for other people who don't find it fun, it's more of it's a job where you're actually lending the money to your future self. And then you have to get them back in salary over the rest of your career. And that's it's a whole balancing thing. You have to figure it out. And so for tools, we have to look at the same thing. And frameworks, we have to look at the same thing. What's the cost of learning this thing? Is it fun for you? Did you accidentally already learn it by having another job or a school or somewhere? If you already know React, it's a lot cheaper to put React in your next project than if you meet someone who doesn't know React, and it's like you have to factor in, this person has to spend 6 months, a year before they're proficient in React. Yeah. And it's like that's a really big portion of the cost that generally is just not factored in, I feel, when we talk about these frameworks and put them in things. And it's almost always because the people advocating them has already spent the time learning it. Yeah. Right? We had I was doing a project once where we wanted to build a new cool app thing. We were two of the most talented developers I'd ever met, joined me on the project. And we were like, we'll choose all the cool technologies, right? We'll choose all the best things. We'll research everything and say, what is state of the art right now? And we found, 30 tools, 20 tools that were like, these are really cool. And these are the bases. And we'll just have to tie them together. And then we'll have a cool app in no time. But it turned out that already at 2 or 3, it's like, I'm so tired of not being productive. I'm not adding any code. I'm just sitting here reading tutorials. Yeah. And then because they're modern tools, they're not quite suited for everything, and they're not quite ready for my specific use case. Mm-hmm. I have to spend so long doing all the other thing. And whereas it's the wrong way to start. You shouldn't start asking, what are all the cool things I want to add? You should start with, what can't I postpone, right? Yeah. And if there's any tool or framework where you're like, oh, I can actually postpone this 6 months or a year, do it for God's sake. Like, wait, because hopefully you'll never get to the point where you physically need it.
Yeah.
And I also really like building the tools myself, so I understand how they work. Again, it took me a long time before I could do it with React. Yeah. But for a lot of things, it's like you can get pretty much the 50 or 90% you use of a tool fairly easy in a lot of cases. Not all cases, for sure. And when you can demonstrate, I have something here that I can't solve myself, then add a tool, for sure. That's cool. But now you have something, and then also I would say document it, right? Take that snippet of code or that problem statement, put it in some design document where you're like, this is why we have this tool. It's this specific problem. And if this problem goes away because the change of the users or the users change or the need changes, or you deleted it, remove the tool also.
Yeah.
Right? You have something driving every decision. You should be able to, when I visit your company as a consultant to do an architecture review, you should be able to point to a specific problem that each thing is solving. And otherwise it shouldn't be there.
Yeah. Yeah. I mean, it's
the basic programming languages can do a lot.
Yeah.
Like they're Turing complete. They can actually do everything.
Yeah, so, exactly. And I mean,
you don't need anything.
No. And I mean, it's always the case that whatever framework you find for a problem is solving a much more general problem than the one you're having. Yeah. And that makes it look kind of advanced because you feed it these parameters and an answer comes out. But maybe my particular instance of the problem could actually be an if statement if I just thought it through a bit longer or wasn't scared by the fact that there's a big library for solving this.
Yeah, that's a really accurate point. It's a really good point. I also talk about that in the book where I talk about generality actually adds complexity. It's like if you have something that can solve 100 problems, it's much harder to get rid of that thing because now you're calling it in 100 different ways. Whereas if you just had 100 instances of it, or maybe 50 instances of it, you'd be able to identify, one of them has gone away. I can remove it.
Yeah.
And some things we like to be fairly general, like the math library generally doesn't change a lot. I think the more often something changes, the more specific it should be. And then you should move towards being more general. And then eventually maybe you could do a library or something like that. But it's much harder to delete. Already when we had some small function or something we were using in a lot of our components in the current system, and we pulled it out into a library so we could maintain it centrally instead. The thing is now we have to have a whole release process for it, right? We have to release the internal library. You have to go into all the services that use that library, and we don't have like a catalog of this. It's because it's decoupled. We don't know which libraries or which components technically use it. We have to go into all of them, check if they use it, recompile them, rebuild them, redeploy everything. This is not simpler anymore.
No.
Right? It has a cost, and we have to think, is it simpler to just have some code around the place?
Yeah.
And it depends what's the risk of that code being ill-maintained, right? What if I don't update it one place? Well, that same thing could happen with the library. Okay, so like we have to like all of that goes into it. And it's just take things out and there are just so many tools that people add. Kubernetes is also exploding with things you can add to it and all these other things. I've seen people also, we need higher code quality, so we bought SonarQube. Like,
we added more.
But you did, and you didn't. It's not. You can't point to something that SonarQube is solving for you, right? It's just saying what your code quality is.
Yeah,
and it might improve the code quality. I'm not going to say it won't. I'm just saying it wasn't driven by an actual need. It was driven by some abstract need that you decided you had.
Yeah,
it's not a concrete. We have. Like the cyclomatic complexity is too high. Okay. Is there a simpler way to address that? Could it be teaching the developers how to avoid it? Could that be a simpler thing without a tool? And I much prefer skills. If I can teach the developers something that they can use for the rest of their career, by the way, and improve the code base, it's a much simpler solution.
Yeah.
Occam's razor, just cut out all the things.
Yeah. I mean,
we added this to our pipeline. Like,
Oh.
yeah, and they add SonarQube, right? And it gives them 30 other problems than their cyclomatic complexity. And it's like, well, you went from having one problem, so now you have 30.
Yeah.
But none of them came from the developers, maybe,
No.
right? It could be. And it's,
Yeah.
oh God, and you have to prioritize these things. And it's saying this one is red, but the cyclomatic thing is only yellow. So which one are you going to focus on?
Yeah, exactly.
Especially, again, if you move the decision process to someone who's doing the finance or looking at graphs instead of looking at the code.
Yeah.
God, it's just, can we just take out everything, open up an editor with a clean JavaScript or Java or whatever, and just write down the code, please?
Yeah. And then you sit staring at the code, and then you think, if I just had something that let me look at this on a higher level, I can't quite grasp it at this level. And then you're sort of back into generalization land again.
Yeah.
It's hard to find the right.
But it's sort of as if, it's sort of the same that the capitalistic system does to consumers. It tries to push products to them. And in the same way, code is doing that, right? It's like, I really want you to add more general things, right? Or we're educated to the don't repeat yourself thing. And it's like, I can actually take these 2 lines of code and combine them into 1 line of code with 3 lines of library in quotes, right? Or whatever. It's like, maybe, but is it simpler? Is it better? And the IDEs are getting these pop-ups where it says, it looks like you could use another extension. What about something that can do this? Or what about something that can do this? I'm like, no, stop suggesting I add things. Like, suggest I remove things. It looks like you haven't removed this for a month. Remove it.
Yeah.
I would much rather have that.
That would be
Get
great.
things clean for me.
Yeah.
Right?
Yeah, exactly.
And AI is going to do that as well. It's like, I see that you're trying to type something that can add numbers. Let me just import a bunch of libraries for you. Do this other thing.
Happens all the time.
No. Push it out.
Yeah.
I want less.
Yeah, exactly.
Less code. Suggest what I can delete.
Yeah.
Suggest what I should add.
Yeah, I mean, the stuff I write myself is more than enough to confuse and complicate things. I wouldn't be helped by having libraries in there.
Yeah. I've said, I think before, that I think deleting code is going to be the next big improvement we can do to code. Finding a way to delete something and get rid of stuff is the biggest problem I think we have.
Yeah.
All the other things we actually have a pretty decent grasp on. We're good at maintaining code. We're good at writing systems. We've already built Netflix, so we can clearly do stable software that just works.
Yeah.
So how do we get rid of things, right? How do we simplify them back down? Make them elegant again.
Exactly. Especially when
find the right abstraction levels.
Yeah, and reevaluate them over time, I guess. I mean, I find it really hard to get into the right mindset for that. I mean, I have quite a few things which have grown for a while, and I feel like this should be possible to straighten out in some way or multiple. And I start looking into it, and it's all these cases that were added because people actually needed them, and then I sit for a while, and then I start thinking, maybe pulling this thread. I say, no, it's all this stuff, and then I don't get anywhere. so I feel like sometimes I would need a change of mindset or something to, progress in the direction of simplifying it.
Yeah, developers are problem solvers, and we're good at it. We spend our entire life training to solve problems. And one of the harder things I really try to make developers do is slow down a little bit once in a while, to have think before we start solving, right? Not about the solution, but before the solution. And especially my co-founder, who's a very talented developer also, when we're sitting out discussing what we want the thing to do, sometimes he'll mention, we have this thing with something, an exchange protocol or whatever. It's like, and he's like, I can build this extra thing to go and snap that and then do this and transform it a bit. And I'm like, is this a problem we should have? Like, I'm not saying the solution wouldn't work, but it's just, is the problem correct? Like, is this the right problem to have?
Yeah.
Or do we just stumble into something that we can also accidentally solve, but we shouldn't actually solve it? It's not something anyone should use or do. People request, I really want to be able to do. I have another friend who's also doing a startup of building a system where they can transfer data from one supplier to a bunch of whatever retailers. And it's like, then somebody asked him, "Hey, can you host the contracts we do with other people?" I'm like, or he was like, I mean, we can host. I guess we can host that data, but it has nothing to do with the fact that we move data from one place to another place. It's just coincidence that we can host it. And he's like, "Yeah, I would like a preview of the PDF." It's like, I mean, sure, we can solve that. It's just that's not a thing you should do with this platform. It's something you should do with a document database.
Yeah.
Or like Google Drive or whatever. But we get these problems, and if we're not careful, we start solving them. Because of course we can solve it. Sure.
Yeah, of course. I mean, it's possible. It's doable, especially with an extra library.
But should you solve it? Does it fit here? And does it fit with the strategy and stuff? And that tugs into another thing I love to tell a lot of companies. You should have leadership in all of the levels of the organization. You should have it right on the next chair to the developer. Should be a tech lead or a product something that can tell you, what is actually the strategy for this product? Does this fit into the vision we want to build? Should we have a PDF preview on the website? Because sometimes the user can has the phone number of the developer, which can be very dangerous.
No,
and then they just call them and say, "Hi, I saw you added this thing. That's good. Can you add this other thing?"
Yeah.
And it's outside of a product flow, and but does it fit in the strategy? Like, does it fit in the architecture? Does it fit anywhere?
Yeah.
It's just, I want to say no more.
Yeah, exactly. And I, to tie things back to stuff you talked about before, having thought about like what the principles and the model is for a certain system, having stuff like that to lean on can also actually make it easier to say no, and say no with a reasoning that's actually easier for the person receiving it to, understand and accept as well. This doesn't actually fit into the model of what we're doing here because X, Y, and Z.
Yeah.
And someone might get and then you think, oh no, they're going to be so mad at me. And then it turns out the reaction is, oh, okay, that makes sense. And then and then everyone's pretty happy because you actually had something to support saying no.
Humans have this presence bias where we think whatever we're in right now is how the situation is going to be forever. And that means, of course, that the problems that you just sat with right now seems like they're going to be there forever, but they might not be, right?
No.
And hopefully a talented architect will find principles that actually help people for, let's say, 8 years is the average lifetime of a system. So they'll help people for the remainder of that time. Whereas whatever problem you just had, if you sacrifice one of the principles, not only does it invalidate everything that came before, but also make everything after that harder. Like all of I do, so I'm very math-based, and I do a lot of, I secure the system with proofs and a lot of math. And I'm like, I design these principles, and I prove that then you will get all of these advantages that are really cool and really powerful. And it's something I can say with certainty because I did the math. I know it. But if you go in and sacrifice any of the things that I've said here, any of the designing principles, you don't have it. Like, it's all bets are off and you're on your own.
Yeah.
And they keep, especially the direct communication is so hard to get rid of. I don't know why people like it. It's just bad, at least from a math perspective.
Yeah, of course.
So I have all these things. You can do all the refactoring. You can do all of these things. It scales in a very nice way because it's message queues and things. And it's like, okay, cool. But we also want to call this one directly sometimes. It's like, no, you can't do it even once. But they're like, what if it's really important? Exactly. It's like, it's the same as dividing by 0. You can't do it's just no. I mean, sure, we can design a direct microservice architecture for you, but you'll forego everything that I've given you. We'll have to start from scratch. But that, I mean, I did go by the hour, so that's fine by me. It's just,
Yeah, but I mean, it is a really good point as well that once you've done it, you've actually ruined a principle and an architecture potentially and things like that. Yeah, because I've definitely done stuff like that on a micro level inside of one app and stuff like that. It's like, yeah, things flow this way, but this thing, it would be really convenient if they just sent a special message straight through over there, and then you do that, and then that's a trap for you to rediscover every now and then when you wonder why things work the way they do. But then if you didn't have a nicely formulated theory when you started, you can't really fall back on that either. Then it's just each time you rediscover this thing, it's like, yeah, I guess this is the way the system is.
Yeah, but you have to discover it then, right? Your developers have to do archaeology on your code to figure out, well,
Exactly.
how was it actually working?
Yeah.
Because we can't rely on the principles that it was founded on. We can't rely on the advantages. If you have some simple principles like, say indirect microservice or indirect architecture, then you can rely on some invariance that comes from that, right? I know. I don't need to check all these things. I don't need to handle what if someone takes too long to respond. That's not a thing that can happen in an asynchronous architecture. There's no response doesn't mean anything.
Oh yeah.
And whenever people say like, oh, I can trigger, they say, oh, but how do I then wait for this one to get back to me? It's like there's no back. There's no direction. You can trigger something, and that can trigger another thing, and that other thing can also be you. But I mean, you also can't preserve any data between these two because they have to be stateless, right? So but they're like, no, but I just want to preserve a little bit of state.
Exactly.
No. Because when you preserve a little bit of state, you again can't have multiple instances of something, and you lose the zero downtime deployment. Also, it's like you know. It's a house of cards, but it works if you use it in the way that it's intended.
Yeah.
Like all of this is well designed. It's just, you can't just do anything to it. You have to follow the 3 rules. And I see a lot of or some people try to do more than 3, and that can be fine. It can also be a little bit overwhelming for the developers, but at least it has to be communicated very clearly, and it has to be on a very sound basis, right? You have to sit down and think really hard when you do the first things, because it's when you have nothing that you can actually make changes. It's way harder to make changes once you have something running. Then you have to go and refactor it, right? And it involves a lot of other people. Right when you sit down and design an architecture or a target architecture you want to go towards, that's when you can make these changes and say, if we can do this, then, I mean, we can make these guarantees.
Yeah.
And if we can't, then we shouldn't do anything at all. Or we should design it differently from the beginning.
Yeah.
There's no point in pushing towards something that you know you can't do.
Yeah.
Like you shouldn't make a real-time architecture for something that people need to download. Obviously, they're not going to download it in real time.
No.
I mean, actually, they're never going to download the next version. Or they do it 2 years later. So then you have a different set of principles that you need to satisfy or that you need to work around.
Yeah.
But I'm pretty sure, and that was my initial thesis, that there is no situation where simplicity shouldn't be one of the principles of whatever you build.
Yeah. Yeah.
It's universal. Removing things is better.
Yeah, exactly.
That's just it.
Yeah.
And everything that you add should pull its own weight. It should bring in the income that makes it worth it.
Yeah.
Or the usage, or however you value your system.
Yeah, exactly. And if it stops being valuable at some point, it should probably be removed as well.
And that's the interesting thing. If someone can make a startup that discovers what value has been invalidated, that will be worth a lot of money.
Oh yes,
right. It's really hard to figure out what has changed, but that's a valuable area of trying the next thing. I'd love to do like a book and research and stuff on how do we discover that some code is irrelevant now?
Yeah.
It's become irrelevant.
Yeah.
It's like cache invalidation. It's one of the hardest things to know.
Yeah. This is system invalidation or principle invalidation.
We already know that even finding a metric for your system or for each part of it, we also want to know actually, it'd be nice to know what's the value of each team that we have. How much are they contributing to the thing? But that's really hard to figure out. We have to have really clever financial analysts who've come up with metrics and stuff. So actually A/B testing is already hard. But then if you have something that works like that, you can sort of start to get a gauging of what each component, what each service, something like that is actually contributing to the system. It's very hard.
Yeah.
Again, Netflix can do all of this, so it is possible. Like humans can build this.
Yeah.
We just want to make more humans able to build it.
Yeah.
That's sort of my mission with the company. I want to get to a place where if you just use our platform, you'll be at that level. But so far we've started with serverless. Yeah. We'll move towards all the A/B testing and all of the other stuff.
Yeah.
Slowly, but I really want everybody to build the awesome software that we know humans can build.
Yeah. And I've got some ideas for cleanup I want to do in my own code as well, well aside of the framework. So it's good on all levels.
Yeah, I mean, getting things out is awesome. When people say I've added this many lines today, I'm like, how many did you remove?
Yeah, that's the best.
It's way cooler. And if you do we like to do immutable, and we have all these other things, and then it means you can it's easier to take things out, because when you've added a bunch of stuff, the IDE will tell you these things are just literally not called anymore.
Yeah.
Cool. Gone.
Exactly.
Out-commented code, gone immediately. I don't want it. Delete.
Yeah. Maybe that's a good place to stop for today.
Yep, that's cool.
Yeah, this has been great. Where should people go if they want to talk to you?
If they want to talk to me about infrastructure or like microservices, something like that, or platform engineering in general, they can just book me directly from merrymake.eu, my company website. And if they want to read more about the things that I care about, they can go to my blog at the Dr. Lambda on Medium, or my book, of course, 5 Lines of Code.
Yep.
I also generally try to interact with people if they write me on any platform where they find me, but I am also pretty busy, so allow me for a pretty long time's response time.
Yeah,
I will eventually get around to it.
Yeah, exactly. Just like I did with this. Eventually, I got there.
Exactly.
And of course, all the links are in the show notes, of course, for everyone to find.
That's cool. It's been a pleasure. I'd be happy to come back and chat about another time.
Yes, we'll definitely make that happen. We have a really, really fun list of things we could go through. Yeah, thank you so much.
Thanks for today.
Tack för att just du lyssnar på Kodsnack. Om du vill stödja oss, varför inte tipsa en bekant om podden? Eller lämna en recension i till exempel iTunes eller något annat ställe där det går att sätta betyg på poddar. Du kan också stödja oss genom att köpa oss en kopp kaffe på Coffee, ko-fi.com/kodsnack. Alla pengar går direkt till att göra podden bättre och trevligare. Du kan också komma och hänga i vår Slack-kanal. Länk finns på kodsnack.se, precis som alla andra länkar och all annan info kopplat till varje avsnitt. Sist men inte minst finns det också en länk till vår Spreadshop-butik där du kan köpa tröjor och andra prylar med Kodsnack-tryck. Återigen, tusen tack för att du lyssnar. Vi hörs.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.